Okay, welcome to part 2. If you haven't, you should probably watch the first part of this video. Um, but, or I guess not. This is another new refactoring. So now we are at the point where we have some student code that I've debugged and refactored a little bit. That has a sort of playing part of a Connect 4 game. It's really not Connect 4 because the pieces don't drop, but it's sort of 4 in a row. And in the last video, I refactored the thing that checked for a winner from a bunch of hardwired code that didn't actually cover all of the possibilities to now these 4 loops that handle, as the comments say, verticals, horizontal, and the 2 kinds of diagonals. As I have said in class and probably in previous videos, whenever we have a big function, so this winner is still over 50 lines long, and it's made up of these 4 chunks that I had to comment to keep straight what they are. There's 2 choices. One is to break these out to separate functions, and then this would at least be shorter and it would call, check verticals, check horizontal, check diagonal 1, check diagonal 2. And that would be fine. But in fact, these chunks of code are very similar. And so that makes me think, can I just turn them into one chunk of code? For instance, like the difference between checking for vertical and checking for horizontal is like the loop indices go to slightly different places because we can't check for vertical too far down on the board, but when we're checking horizontal, we want to check every row, and conversely, the columns change and the diagonals have a little bit of the flavor of each of the others, and this diagonal starts at a different place. And then what happens inside the loop, the pattern of whether we're adding or subtracting is a little bit different. And then there's another little bit of duplication here I noticed, especially in these where I very explicitly add 0, add 1, add 2, add 3. This one adding in both, and this is subtracting and adding. So let me first come up here and make this one just to make things consistent, to emphasize the pattern. This is really some starting row and then plus 0, 1, 2, 3. 0, 1, 2, 3. So all of these are 0, 1, 2, 3. So that is also crying out for a loop, right? Because why should I have to hard code the sequence from 0 to 3 when I could just write a loop? So first, let's see if I can condense this. So now I'm finally going to come back to the original loop that was in the student code. They had a loop with I, our traditional index variable, and I'm going to add another brace down here, hit reformat to make sure I put them in the right place. And now this is going to be a little bit different because this is a one Boolean expression that's checking 4 things. Like, is it this one equal to m, and this one is equal to m, and this one? Well, that's kind of a, if you remember our for loop patterns, it's an every or an all pattern, right? All of these things equal m. And so when we do an all pattern, we can, what's the way I want to do this? I'm going to make a Boolean value which says that they are all the same. So same equals true. Is this right? And then if one of these, so we're going to use our variable I, is not equal to m, so I'm going to basically get rid of this and get rid of that and move this one up here. So basically, if we find one of the 4 marks starting from our row and in that column is not equal to m, then that means they are not all the same. And so, and then instead of returning, we're going to say same equals false. And then if we get through that loop, then either we will have seen one that doesn't match and have set same to be false, and let's see. Sorry, we want to do this outside of the for loop. Okay, so we're going to assume that all four will be the same, optimistically. And if, in fact, we see all the same ones, then same won't change. It will be true after this for loop. And if we ever saw one that didn't match, it will be false. And so if not same, if we got to the end and we saw one, we can return true. So this is a little bit tricky because we have this sort of multiply nested loop where we got to check a whole bunch of rows and columns, but at each one, possibly there's a winner where we're going to check the four rows from that row and column, and then if none of them are different, that means all four of them are the same. That means we found a winner and we will return true. But if we didn't find, like if this was false, that meant that particular vertical was not all four in a row, then same as false. But we don't want to return false because unless we're on the last iteration of these loops, there's more rows and columns to check. So this is maybe a little bit getting a little hairy just because we've got 3 levels of nested loops. And so this is a place where now it's maybe worth breaking out a function. So let's take the body of this loop, and for starters, I will copy it and I will put it up here just so we can sort of see it at the same time. And I'm going to make a function. And so what is this function checking? This is checking a vertical. And now I need to look at all the variables that it references. And it's got references R and C because those are coming from these loop variables. And marks is global. And the other variables are all declared inside here. So we can make that, and M, the mark itself. So we're going to take R, C, and M as arguments. Reformat that, see that that gets indented. So far this is basically the same, but now we can make things a little bit simpler because this function is only checking one R, C, and M. We can get rid of this variable. As soon as we see a mismatch, we return false. And if we get to the end of the loop, we return true. So we don't have this complicated extra layer of variables. So this is now just a regular application of the sort of every pattern. We're asking, is every one of the cells, every one of the 4 cells, starting from rows and going up by 1 and staying in the same column, equal to the mark we were given? And if any of them aren't, we return false. And if they all are, we return true. So this is a regular any pattern. And so now, now it's maybe a little more obvious that if we say if check vertical row column mark, right, if it found one that's the same, then we return true. And check vertical could probably be named better, and we can say, let's call it is vertical for in a row. So that's a little bit long, but it's quite clear what it does. Okay, and so that uses this I 0 to less than 4 loop to check the 4 in a row moving down in the rows. The row value goes up, it goes down the board. And so now you can kind of imagine a very similar thing happening for each of these other horizontal, diagonal, diagonal 2. So maybe we can even leap ahead and say, well, what if we had is a horizontal, and we assume we're starting at a row and column that are legit because the loops are taking care of that for us. But we're still going to loop 4 times. And so now we look at what was the pattern in the horizontal. In that case, the row stayed the same, but the column went up by 1. So we just change row C plus I, and then otherwise it's the same. So if we see a mismatch, return false, otherwise we return true. And I haven't actually tested this in a while, so let's save right here. I actually replaced the vertical checker with my new function. I've left the other code. I wrote this function, but I haven't used it yet. So I can come over here and see if the verticals still work. And indeed they do. In looks like a lot of the columns. So that gives me some confidence to then come here and say if is horizontal 4 in a row at the given row and column with the given mark, return true, just like we did in the previous case. And make sure my braces match up. So that's good. And so now you can kind of see where this is going. Again, I'm copying and pasting, which suggests that I won't, and you can kind of see we're going to make 2 more functions. Diagonal 1, diagonal 1 will be our up and to the right. And it follows the pattern of adding to both. So the fact that I'm doing all this copy and pasting suggests that after I've made these 4 functions, I won't necessarily be completely done, but we may be able to combine these functions in some way. But for now, let's keep going. This is getting simpler. My diagonal 2, now the rows go down by 1 each time, and the columns continue to go up. So that's as simple as changing that plus to a minus. And so I should be able to, if is diagonal 1, 4 in a row, row column mark, return true. And I should be able to replace this. If is diagonal 2, 4 in a row, row column mark, return true. And if I didn't have any typos, suspect, oh, I did break it. That's funny. How about up diagonals? Okay, fascinating. Well, that's quite odd. Did I check the horizontals? So that still works. Oops. That one still works. Okay, so what did I do differently? Is diagonal 1, 4 in a row. Oh, look at that. Copied the wrong thing. R plus I and R minus I. I guess I must have just typed the wrong thing. Okay, so again, sometimes good to test and see. Having only made a few changes, it wasn't too terrible finding a place I had messed things up. And now it looks like the diagonals are working as expected. Okay, so yeah, 1 minus, versus I, obviously a pretty important difference, but also pretty subtle. The characters look the same. Okay, so now this is a little bit shorter, right? Remember this used to be about 50 lines and now it's 30. And these functions that we made by cutting and pasting are also pretty similar. And then we also have these for loops that are all now very similar, except they call a different function and they have different constraints on how far they go, right? Because we can only check for these things in different places. So this next maneuver is a little bit, just requires a slight twist of how we think about things. So what if instead of having these functions assume that they're called with a row and a column that where there is room to loop 4 times and check, what if maybe they contain the knowledge about whether that's the case? So for instance, to check vertical, we're gonna add up to 3 to the row value we were given. And so that means if the row, like we can even look here, what is the condition? So we loop as long as row is less than 3. So if row is greater than or equal to 3, meaning 0, 1, 2, 3, like if it's equal to 3 or is 4 or 5, like there's just not room for a vertical like we're checking for. So that means if we are given a row of 3 or more, there's definitely not a vertical at that spot. So we can just say return false. And then only if we get past that check do we then, now we know that there's space, and so we can check all 4 cells. And so if that means that this actually would work even if we called it with 4 or 5, 3 or 4 or 5. So that means we could, it's kind of silly here, but bear with me. I'm going to change this loop to loop over all of the rows, and then isVertical will now protect us from going out of bounds of the array because it knows just to immediately return false. So now if we start high enough up, it still detects the winner, but if we start lower down, it doesn't, no problem, no errors over here, because this is just immediately returning false. And so what's the point of this? Well, the point is I can do the same thing. So horizontal, the rows, there's no constraint. We're going to go over all the rows, but the columns have to be less than 4. So conversely, if the column is greater than equal to 4, there can't be a horizontal 4 in the row with that position as the leftmost piece. And so this one, we can now change to be all of the columns. And again, you might be wondering, all right, what's the point of that? So we're checking a horizontal. This should work because it's 4 in a row, and this one should not do anything, no errors, but so we actually called isHorizontalRow for those higher columns, but it just returned false immediately. Okay, so the point of this is now these 2 loops, 2 sets of nested loops, are exactly the same. This is going from 0 to mark's length, and this is going 0 to mark 0 dot length, as is this one. So that means we can copy this up here and get rid of this loop altogether. And horizontal. Okay, but you can probably see where this is going. We can do exactly the same thing with our diagonals. Now, the diagonals, remember when we made the loops, we sort of copied them from a mixture of the vertical and horizontal. So down and to the right has the same constraint as those other ones had. So like we're going down like in a vertical, so that means we have this constraint. If we're asked about a diagonal where the row is too big, can't be, has to be false. And if we're asked about a diagonal where the column is too big, also has to be false. So we do both of those. Otherwise, check the 4 things moving the way we move to move diagonally. And if we've done that right, we should be able to take this. This loop will now do nothing, but we'll just leave it there for a second. And so this is our diagonal 1, which is down and to the right. And that works. And if we go to one that doesn't go far enough, no problem. Okay, and so now the very last one, this has the same column constraint. So we'll go ahead and copy that. And then the row constraint is a little bit different in that we only want to check these ones when we start. This one is different. It's not in the loop condition. It's where we start. We start with r equals to 3. So if r is less than 3, right, 0, 1, or 2, that's when there's not enough room to go up and to the right. So that's when we're going to return false from our diagonal 2 function. And so we can copy this, or cut it actually, and put it up here. And now all of these 4 functions are running in the same loop that's essentially checking every row and column of the board, but these functions only check the ones where it's possible for there to be space. And so now we can check our upwards diagonal up to the right, and that works. And that doesn't cause any problems. And so we can now safely delete these 2 loops. And now we don't even really need this column, or this comment rather, because it's pretty clear what's going on here. So now, have we made things smaller? We've made this function smaller for sure. I'm going to move it up here because it's kind of, it depends on these. And now I look at these 4 functions and say, well, these are all kind of the same. So this may feel silly, like I'm breaking things out, but then making them the same, and then saying, well, now I've got 4 functions that work kind of the same. So I want to combine them. But this is actually sort of the ebb and flow. All right, but before we do the next step, let's commit what we've done. Take a peek. So we have broken out the 4 functions. So let's just say that. Broke out 4, and I guess this is, yeah, so 4 direction checking functions. All right. Close that. Okay, so now I want to turn my attention to these 4 functions that are pretty similar. Difference being how we move through the array, plus or minus, and rows and columns, and then also the check here. And so to do this one, I'm going to copy one of these, and I'm going to make, now I'm trying to make a more general function. So this is kind of like way back in the last video when we combined the 2 check winners that one did red, one did yellow into one by abstracting the idea of what mark it used. Now we're going to abstract by saying, okay, the difference in these 4 functions, the main difference is how the rows and columns change. So I'm going to make 2 variables, dr, which stands for, well, delta, which stands for like change if you're in physics, and dc. This is a nice short name. So this means like the change in the r and the change in c. This is the kind of common naming convention that comes from math and science, I guess. But anyway, d just stands for change. And if I had those arguments, and they might be 1 or 0 or possibly -1, then, so let's just say like this original vertical 4 in a row where the row is changing by 0, 1, 2, and 3. Well, I is 0, 1, 2, and 3. So if dr was 1 and I multiply 0 times 1, I get 0, and 1 times 1, I get 1, and 2 times 1. So if dr was 1, right, this would be obviously the same as just I. And let's say for the columns, I'm going to add I, the loop variable, times 0. Well, that's obviously also really the same thing because anything times 0 is going to be 0. But this is where I want to put in the variables. So if dr was 1 and dc was 0, this line of code would be the same as this line of code. But we can also see that if dr was 0 and dc was 1, it would be the same as this line of code. And likewise, 1 and 1 would be the same as this, and -1 and 1 would be the same as this. So now we have a way to make this line of code act like any of these 4 in the other 4 functions. And then the other thing we gotta look at is, what are these conditions? And if you recall, we copied a lot of these from different ones. And which ones we needed to use really was determined by how the rows and columns were changing. So when the row is going up, then, and we have to check and immediately return false if the row is greater than or equal to 3, because we're going to go up by, we're going to add 3 at the end, and if that goes out of bounds, we have a problem. So we can change this to if dr is greater than 0 or equal to 1. Either way, I'm going to say greater than 0, meaning that it's positive. So the row is going to be increasing, and the starting row, r, is greater than or equal to 3, then we have to return false. By a similar token, and so that will handle this vertical case here, and we'll handle this case for the diagonals, or the diagonal down. So then let's look at this other condition that we have in some of these, like c greater than or equal to 4. Well, that similarly is when c is going up. So if dc is greater than 0, that means we're going to increase the column, which means there's not enough room if c is too big. And so if c is greater than or equal to 4, we can also immediately return false. And so that makes basically this line is the same as this line in the cases where r is going up, and this line is the same as this line when r is going down, or sorry, when r is going up, when c is going up. And then, so that will handle the diagonal 1 case, and the diagonal 2 had one other condition because its r's are going down. And so that's if dr is less than 0, i.e. -1, and r is too small, then we can immediately return false. And so these 3 lines handle the appropriate checks that were sort of hard-coded into the 4 other functions. And so, and that's a consequence of these values. If r is going up or c is going up, then we want to check for different constraints. And then, like we said, we made this line behave the same as all these others. So now what I'm going to do, actually what I'm going to do is I'm going to comment out, copy this line. And some of you have learned triple click, 1, 2, 3 clicks, copies the whole thing, or selects the whole thing, Command C copies it, and now I paste it. I'm going to comment out the original, and I'm going to see if I can replace it with a call to our new function. So we said is vertical 4 in a row is when the row increases and the column stays the same. And so now the test is, can I detect a vertical wind? I can. Can I not crash when I go out of bounds? Also seems to be the case. And so that suggests this line has replaced this line. And now I'm going to go ahead and comment out those 3 lines, triple click that, copy it, paste 3 more copies, and horizontal, I just have to change the arguments, is 4 in a row with the row is unchanging, column going up by 1, diagonal 1, which I'm replacing down here, is row is going up and column is going up. And then finally diagonal 2, row is going down and column is going up. Save that. Let's test some different things. Let's test it downward to the right diagonal. That works. Upwards to the right diagonal. That works. Horizontal in some random place on the board. That works. Okay, so that suggests that these lines are no longer needed, which means that these 4 functions, which we abstracted, right, these are kind of concrete, check vertical, check horizontal, into a more abstract function. It takes more arguments, where the arguments express the difference between these 4 functions. And so I can just delete these. And so now I have, from the original kind of, what was it, like 200 lines of 2 functions that were checking a bunch of stuff and not actually checking enough, I have this sort of 4 or 5 line function that just contains our original if and like the actual logic of what happens when there's a winner. And then this is winner function that mostly its job is to loop through all of the positions of the board and then check for a 4 in a row in the 4 different ways there can be: horizontal, vertical, and diagonal. And then in 4 in a row, checks one of them, uses the loop to walk 4 steps in the appropriate direction, and it knows enough to know how to not go out of bounds. So there's, as always, slightly different ways to do this. You could also just check in here that you're still in bounds, and if you're not in bounds, return false. Or, but this seems like a reasonable way to transform what we had into what we want. And I guess one last little subtlety is, now that we have this all abstracted, we actually don't need to check winner twice, right? We check for the winner of a particular mark. Well, assuming no one has won already, the only mark that could have won is the one that just played. And so I'm going to do it this way. I think I did this in the previous video maybe. I'm going to make a variable called mark, and I'm going to use the ternary operator, which I think I've shown in the video before, which is basically like an if, except it's an expression. So this is a Boolean. If, same Boolean we use down here. If the move is even, then the mark is red. Otherwise, after the colon is the value if the Boolean is not true. Otherwise, the mark is yellow. And then we can get rid of this if and just use the mark. And then check for winner with the mark that we just played. Format document. So that's not a big win. And let's see. I guess we can move that. Sorry, that should be inside this if because there's no point. We don't need it. So we get the mark. We set it on the cell. We set it in the marks array. And then we check for winner with that mark. And so that makes things a little more efficient because we don't bother checking for the other piece because I couldn't possibly have just won. All right. And so now we have lines 39 to lines 68. So that's actually less than 30 lines of code into 3 separate functions that are a lot simpler. Right? This is, and they all do sort of one thing. This just checks and updates the text and the game over. This actually does the cell by cell checking, and then this checks for 1, 4 in a line. Oops. So it is more abstract. So there is a little bit of like, this is 4 in a row, it's a little, RCM10, like what is going on here? But it is also it's like a pattern. It kind of makes the pattern very visible. We're checking in these 4 different directions. And once you understand this, you might have to scratch your head a little bit over what are these conditions, but they ultimately make some sense. And this loop is very simple. This is an every loop. And that is that. So I think one last commit, basically done, refactoring, check for winner with that. All right. And so another video down the hatch. Hopefully that was useful. Obviously your code, unless you are the student whose code this is, will be slightly different. And so you may not want to end up exactly here. Obviously you could just like type this code in, but that's not really the point. The point is to get practice at going from what you have to something simpler. And so some of you maybe already have 4 separate functions that do horizontal, vertical, diagonal 1 and diagonal 2 in some way. And so finding a way to combine them into a single function, so there's just less code to deal with, would probably be the move. Okay, so thanks for watching. As always, hopefully you found this useful. Take it easy.